So the whole checkpoint questions will be covered in a separate tutorial on the checkpoint questions. But since we are doing chromatography, I just want to highlight the application of what I've gone through in the lecture tutorials in a couple of questions, since this is a lecture tutorial after all. Okay, so after you learn the concepts, let's put it into practice. So this question number 6 from the checkpoint question: solution X contains one or more of three substances. It contains one or more of three substances, P, R, and S. You don't know whether it's just one substance, meaning it's pure, or it could be more than one substance, which means it's impure and a mixture. 2 chromatograms to compare X with each of the three substances. So meaning P versus Q versus, P, R, and S. Read the question carefully. So P, R, and S. So this is a pure P, this is a pure R, and this is a pure S. All right. So this is the results. In the solvent 1, it looks like this. Okay, so the starting line is there, but the solvent you use, the solvent must be below the starting line, which is drawn with pencil, which is graphite, and you must take out the chromatogram, you must take out the filter paper before the solvent goes all the way to the top, and you use a graphite pencil, okay, to make a marking at the end where the solvent stops until, and you will have the solvent front. Okay, this is called solvent front. Just now in the notes it was said that this is the ending line. It's actually called solvent front. The distance from the start line to the solvent front, so from there to there, that is the denominator to find out the RF value. Okay, so what do we have here? This is what is happening here. So you have 2 chromatograms, so they are the same X, but they are taken at 2 different times. You obviously allow these to go further, or they could be in different solvent. As you could see, X has moved further, P has moved further, but S hasn't moved further. So here S travel further than P. That's because S and R are more soluble in this solvent number 1. Okay, so they are different solvent. In this solvent 1, R and S are more soluble in solvent 1 compared to P. That's why they travel further in solvent 1. But in solvent 2, P and R travel further than S. That's because P and R are more soluble in solvent 2 compared to S, which is less soluble in solvent 2. That's why it doesn't travel as far up for the same given of time. So let's have a look at solvent 1 first. So we know that if they travel the same distance up, they have the same RF value. All right. So we know R and S are different substances, but by looking at just this chromatogram in solvent 1, it seems that they have the same RF value. So what does that tell you? R and S have the same RF in solvent 1. Does that mean R and S are the same? Not necessarily, because if you look at solvent 2, you will see that R and S have different RF in solvent 2. So it means that they are not the same substance, because if they are the same substance in a different solvent, they should have the same RF as well. They should move the same distance. But here you can tell that R is more soluble than S is solvent 2, because R has moved further than S in solvent 2 compared to solvent 1. So R and S are definitely different. But this question is not asking you on that. It's particularly asking you, what does X contain? So X is this substance. So we can say that the RF value, we can see that they move at the same particular distance in this solvent 1. So X contains R or S. Okay, X contains R or S. Does it mean it's both of them? You see, that's why it is there to confuse you if you just look at one thing. But you must also complete the information and see whether it makes sense or not. All right. So based on this, we say X has R and S. Okay, that is the first information. What does this second information tells you? This second information tells you X has P and R. Okay, but if X has P, then what they should have another spot there in solvent 1. So X does not have P. Okay, it's just that it's a coincidence that P has the similar solubility as R. Okay, in this solvent 2, that P also appears to have the same RF value. The same reason here is not that X contain S, because you can see here X does not contain S because they have different RF value. You see, X and S has different RF value, so it means that you have to refine your argument a little bit. Alright, so P is definitely incorrect, R is definitely correct, S is definitely incorrect based on looking and comparing these two information. So R is definitely correct. So what we can say is definitely X contain R only. S happens to have the same RF by coincidence. P happens to have the same RF, the retention factor, by coincidence of the solubility in the particular solvent. So take the two information together and hopefully you can break down these things and come up to the conclusion that it must be X containing component R only. Let's put it to practice with another question, question 7. So chromatography experiments are carried out on 4 substances, P, Q, R, and S. You use the same solvent in each experiment. So depending on the solubility of the different substances in each solvent, they are going to travel up the filter paper, the chromatogram, at different rate, and therefore they'll move different distance. Okay. So here you can see P only give you 1 spot, same with Q, same with R, but S give you 2 spots. S give you 2 spots because S is a mixture, not just one substance. It has more than one substance mixed together. That's why when you do chromatography, they will separate out because the two substances have different solubility. Okay, different solubility, okay, in that particular solvent, and remember the question earlier which I circle or underline or scribble. That's why we read question and we interpret the information, and we will remember it better if we circle or underline or whatever. Okay, so which statement is not correct? So you need to be very careful. I just said that S is a mixture, so this is a correct statement. Okay, P and Q are pure substances, only 1 spot. Okay, only 1 spot in each chromatogram. So it means that there's only one particular substance in that particular chromatogram. So it's a pure substance because there's only 1 spot in the chromatogram. So you want correct, right? Correct statement. So this is a correct statement, but you want incorrect statement, sorry. Okay, P and R are different substance. I hope you can see that this is the RF value for P and Q, and then this is the RF value, how much it has traveled. So that, and of course solvent front should be somewhere on the top, which you will label it as the solvent front because that is where the solvent move until, and you will take out the chromatogram before the solvent is allowed to reach to the very top of the filter paper. This is how far the spot has moved. You need to divide it by how far the solvent has moved, but you can see different distance that has been moved between that has been moved from here to here. Okay, I better redraw my arrow like that. So there are different substances, so A and B are not what we are looking for. R and S are pure substances. R has only 1 spot, so R is pure. That is true. S is not pure because S is a mixture. It has 2 substances that have different solubility in this particular solvent. There's the same solvent used in all experiments, and we know we can see 2 components there. So S is impure. This is incorrect. So we obtain our answer like that. S is a mixture of substances, as I told you earlier. Question 8, we'll talk about question 8 when we deal with filtration and crystallization. Okay, you can find more about this when I cover the full checkpoint tutorial video. Okay. On to this next question. So this is another chromatography kind of questions. So a student wants to separate a mixture of dyes. You have a mixture of dyes so that you can identify the dyes. You use this apparatus and you also test dye A, B, C, D. So jumping straight into the experimental setup. So they have used a lid, okay, in order maybe to prevent the solvent from evaporating off, because we never know what the solvent is. It could be a solvent with a very low boiling point. So with a low boiling point, it can boil easily and it can escape easily, and you don't want your solvent to escape if it is volatile. Volatile means if it boils easily. Okay, this is the filter paper. It's supported inside a beaker, and what you have is this is the baseline, which you draw using the pencil. Okay, so this is drawn with pencil, and the solvent will slowly move up, and together with each of these pure substance, they will also move up depending on how soluble they are in the solvent. They will move further up if they are more soluble in the solvent. They will move slower, meaning they will not travel a great deal of distance if they are not so soluble in the solvent. With this mixture of dyes, it will separate out into the different components. They will move at different rate depending on the solubility in the solvent, and you have to compare them. Does the mixture contain whichever one of these A, B, C, D, or a mixture of them? All right, and we have to take out this filter paper, the chromatogram, before we can see the solvent move all the way to the very top, and we have to label it with a pencil. That is the solvent front. Okay, so here name the process the student uses to separate the mixture of dyes. This is the process, and this is definitely paper chromatography. So these are technical spelling. They are outlined in the syllabus a lot, so make sure you can spell them very carefully. Next question, it says the apparatus shown in the diagram is set up incorrectly. Explain why. I hope you can remember what I said earlier. The solvent must be below the baseline. Here you can see the solvent. This is the level of the solvent. So that is the solvent level, and that is your starting line. So I meant to see the contrast. So that is the baseline, and the baseline is below the solvent front, and that shouldn't be. You need the solvent to be below the baseline, below where you started. Okay, and that wouldn't work, because once you dip the baseline, which contain the dyes and the mixture, into the solvent, it will smear and it will not have an accurate RF, retention factor, and therefore it will not be an accurate paper chromatography anymore. Okay, so the baseline should be above the solvent level. Or you can do the reverse argument, because you say why is it incorrect, right? Why is it incorrect? You can say the solvent level is below, oops, sorry, not the solvent level, the baseline is below, the baseline is below the solvent level. This is incorrect. So either one is actually saying what is wrong with this experimental setup. Now you set it up correctly, and the solvent will travel up the paper. As you can see, your solvent should really be below the baseline, and you have this solvent front where you take out the chromatogram before the solvent is allowed to reach the very top. The solvent travels up the paper, and it will bring the dyes along with it. As you could see, solvent A goes up, solvent B is more soluble than solvent A in this solvent. That's why it travels a much further distance than solvent A. And solvent C also give you one spot, and solvent D give you one spot. If I think in terms of solubility, okay, solubility in this solvent, if I say going that way is more soluble and going this way is less soluble, so you will probably have to think about which one is travel the furthest distance. In this case, B travel the furthest distance, so B must be the more soluble. D for dog, travels the least distance in the same given amount of time. So D must be not very soluble in this solvent. And then after D, then must be A, then C has the next higher solubility. Okay, so I hope you can appreciate that how far they move depends on how soluble they are in the particular solvent. Now you have the mixture of dyes. I hope you can see that that corresponds to A. They have the same RF value. The distance moved from the baseline, okay, from here to here, divided by the distance from the baseline to the solvent front. It will be equal to the RF value of A. Alright, so it has A, and then it also has C. The mixture also has B, but the mixture does not have D. There's nothing there. Alright, there's nothing there in the mixture that contains D. So which of the dyes are present in the mixture? So it will be A, B, and C, but not D. Okay. Next up, the student identified the dyes using RF values. Okay, so measure the distance between the baseline and the solvent front. So when you do questions on RF, you really have to use a ruler. And I'm doing this on my screen, but depending if this paper is printed out, you would definitely be able to do it on your paper and still get the same RF value because the ratio will be the same. So on the screen, it will be different on your screen because you might be watching this on a TV or on a phone, so the screen will look slightly different. So what matters is when you receive this on paper, you should do it on your paper. Okay, so that's the distance from the baseline to the solvent front. That is 6.5 cm on my screen. Okay, so between the baseline and that is 6.5 cm, but this answer will be different on a paper. So if you're viewing this on a paper, this answer might be different. Okay, might be different on paper, and you should follow whatever you read on your own paper. Okay, the baseline and the position of A. So the one next is the baseline and the position of A. So you should read from the middle to the middle. Okay, so from the middle to the line itself. Okay, so that reads 1.6. That reads 1.6 cm on my screen. So RF value is calculated as the distance moved by the substance, okay, from the baseline, that was 1.6 cm, divided by the distance moved by the solvent to the solvent front. So I'll pop that into your calculator. So 1.6 divided by 6.5. The units cancel out, so RF is a ratio, so there's 0.246. I can run it out to 0.25. That is two significant figure. One significant figure, two significant figure, because the data that I've used is 1 and 2 sig fig, 1 and 2 sig fig. Okay, so this is consistent with whatever data that we have used to calculate it. All right, significant figure is a lower secondary math kind of question. Okay, so we've reached the end of these lecture tutorials, and make sure you ask me questions if you still don't understand principles of chromatography. In the combined science curriculum, it's pretty direct. You probably just need to know that different substances will separate out to a different RF value, and in some cases you do get coincidence where they do overlap like this. That's why you have to think about the other solvent and see whether is it just one substance or is it two substances. All right, but in a more direct question like this, separating out into more than one spot would mean it's a mixture. Separating out into more than one spots would mean that it's a mixture. And comparing it to the pure substance, you can compare not just the RF value, you can just by looking at it, have that travel up the filter paper or the chromatogram to the same distance. If they travel to the same distance, they have the same RF value, because RF is to do with how far up has the substance traveled from the baseline compared to how far has the solvent has traveled. The further you have traveled up, the more soluble is the substance in the solvent. So B has traveled the furthest up, is the more soluble. D is the least soluble, that's why it traveled the least furthest distance. Okay, So that's it from me in this tutorial video, and in the next lecture tutorial video I'll cover the rest of the separation techniques, and you can catch more of the checkpoint questions in another separate video that specifically focuses on all the checkpoint questions. Thank you for watching, and don't forget to subscribe and share the channel. Alright.